Good morning. My name is Tim Bricker, and I'm an instructor with the ESRI training team here in Redlands, California. Co-presenting with me today is Herco Hugeveg and Melinda Theobar. Herco works as a consultant and project manager in ESRI Professional Services here in Redlands, California, and Melinda is an instructor with the SAS Corporation from SAS headquarters in Cary, North Carolina. I want to welcome you all to today's live training seminar. Topics today will include a case study of the Space Shuttle Columbia debris recovery effort, some details on using the SAS Bridge for ESRI to connect SAS and ESRI software. Melinda will be presenting a topic on modeling crime with ArcGIS and SAS. After each topic, we'll have a demonstration, discussion, and review session where you will actually have a chance to ask some questions and we will verbally answer them. And now I'd like to hand it over to Herco, who's going to tell you about the Space Shuttle Columbia debris recovery effort.
Thank you, Tim. In this section of the live training seminar, I'll be addressing how we used ArcGIS and SAS software during the Space Shuttle Columbia debris recovery effort in February 2003. Specifically, I will be showing you how we used the integration of both pieces of software and the linear regression technology to come up with a centralized debris line that was critical in the recovery efforts. If we come back in time, on February 1, 2003, the Space Shuttle Columbia disintegrated over the western USA, spreading debris over an area of approximately 240 by 40 miles in eastern Texas and western Louisiana. Some of the heavier pieces of debris made it all the way down in Louisiana, whereas lighter pieces of debris were found back around the Dallas-Fort Worth area. NASA tasked us to develop a centralized debris line to guide the recovery efforts. As mentioned before, the search area is large and it was critical to come up with a very small focus area in which we would hope to find all major pieces of debris. NASA also gave us a couple of requirements for the NASA debris line. It had to be based on significant recovered items and we needed to have confidence intervals. The significant recovered items are a set of items that are key to discovering why the Shuttle Columbia went down. The confidence intervals, usually you use them to give a measure of how reliable your predictions are, would be used to define our search area. The smaller the search area, of course, the better our predictions and the easier it would be for us to find the debris. The software we used was ArcGIS. We used ArcGIS to map the significant recovered items and get an overview of where they were located in the field. It also provided us with the spatial analysis environment and allowed us to remove some initial outliers. The SAS Bridge for ESRI was used to provide a seamless integration between ArcGIS and the SAS software. It was specifically used to transfer the data from one environment to another. The SAS Enterprise software was used because it had an easy-to-use wizard-driven interface, which omitted the need for programming in the SAS language. At the same time, it provided a robust statistical environment to do the linear regression, and more importantly, it still provided us with the option to compute the confidence intervals. In the next series of slides, I will present a high-level solution of what we did. Our data was stored in a centralized multi-user ArcSDE database that was accessed by up to 40 GIS operators at one point in time. Using ArcMap, we prepared the data, and then using the SAS Bridge for ESRI, we transferred the data from the ArcMap environment into the SAS environment. Then using SAS Enterprise Guide and linear regression, we actually computed a line that would give us an indication of the main path of debris. And then using ArcGIS, we converted the points back to a line. This line was then uploaded using ArcCatalog back into the ArcSDE environment. At that point in time, other GIS operators can use this line to put on a map. This line was put on every single map produced during the recovery effort and provide guidance of more than 35 helicopters and 1,200 people a day on the ground as to where to look for debris. Next, I will go into a short software demonstration on what we actually did. What you're looking at is a map of eastern Texas and western Louisiana. The big hashed area on your screen indicates the initial debris field that was developed by the Forest Resources Institute in Texas on the first day of the incident. This area is approximately 140 miles long and about 40 miles wide. In this area, we have several significant recovered items. As you can see here, there's about 115 items at that point in time that NASA deemed very critical to the recovery effort. These points were used to develop a straight line known as the NASA debris line. In order to get our data out of the ArcMap environment into the SAS environment, we need to export our data. Instead of exporting to a regular dataset, we export our attributes to a SAS dataset. It is key that our data contains the X and Y locations. One of the things we need to do is provide an output file name, and I call it SRL, Significant Recovered Items List. We export this quickly to the SAS environment, and after we have done that, we're ready to go to the Enterprise Guide. In Enterprise Guide, we need to insert our data first before we can do our analysis. We're going to insert the SRL SAS file. This file, as you can see, contains all the attribute information. We have some reference information, a description, but more importantly, a latitude and a longitude. In the task by category window on the bottom, we have an option to scroll down to the regression analysis. As you can see, SAS provides several options: linear, nonlinear, logistic, and generalized linear. We are interested in simply fitting a straight line through these points, so linear regression will be sufficient for us. We double-click the option, and a wizard opens. This wizard interface made it very easy for us to conduct a linear regression. The first thing we need to do is to select a dependent variable, also the latitude. As the X variable, we choose the latitude, also known as the explanatory variable. In the next window, the model, we have the option to select from several linear regression models. We choose a full fitted model. In our statistics options, one of the requirements was to use the confidence limits for the parameter estimates. So we choose a 95% confidence interval, which means that 95% of our observations or debris points would fall within these limits. We also wanted to compute the standardized regression coefficient, the most important being the R-square. The R-square would give us a measure on how well our fit is. The closer the R-square is to 1, the better our fit. We're also interested in several scatter plots, as they may provide us information with respect to the outliers. The first scatter plot we're interested in is observed versus predicted latitude. This should be nearly a straight line in a 45-degree angle. Any points deviating from this line we can consider outliers. We're also interested in the residuals, and the residuals are basically the difference between the mean line and your predicted Y variables. Again, this would provide us insight into the outliers. The predictions, there were a couple pieces of information we want to carry over. The original sample, we wanted to have to know the residuals. The residuals were used eventually to remove outliers. We made a choice of removing any observations for which the residual was 2 times the standard deviation. And also we want to have the prediction limits or confidence intervals. In the last step of the linear regression option, we can provide some titles. We're not doing anything here. We click on Finish, SAS Enterprise Guide will write the code, and immediately generates an output file. This output file is presented to us as an HTML file. Initially, you see here some basic analysis of variance. The most important variable for us is the R-square. As you can see, R-square is 0.9458, which is a very high number. We eventually removed several outliers here, and during the recovery effort, our R-square became 0.99, nearly a perfect fit. So we were quite confident that the line we had was very good, which was important as you guide 35 helicopters and over 1,000 people a day in a multi-million-dollar effort. Here you see a graph that shows the predicted latitude versus the original latitude. This line, these points are on a nearly a straight line with only a few outliers. Here you see the residuals of the latitude versus the predicted latitude. Most residuals are centered around a mean with only a few outliers. Now we take a look at our output file. As you can see, all the original information, reference, action, descriptions were carried over. But addition, we have the predicted latitude and our confidence intervals. The upper and lower limits were provided here. So we're done now in the SAS environment and can go back to the ArcGIS environment to put this line on the map. What we have done is we wrote a little script that would allow us to generate geometry, in this case a line, directly from a table. The first thing we need to do is open this table, and we need to navigate to the SAS Bridge database connection. And Tim will explain to you more about this in the next presentation. We're looking for the output file predicted 6521. That one contains our results. In that file, we select our x-coordinates being the longitude and the y-coordinate field being the predicted latitude, not the original latitude. And we need to select a create in layer, which is debris line. We click on generate and we close this script. As you can see, the yellow line here is our centralized debris line. This line was used for the next 10 weeks to guide all the search efforts. And this will conclude this demonstration. To recap this short case study, NASA was in need of a debris line to guide the search effort. We did a software selection on this, and our final solution was an integrated SAS and ArcGIS environment in which we could conduct linear regression. And at this point in time, we'll take a few questions from the audience. We have one question here. How does the line fit within the preliminary 140 by 40 mile grid? This line falls reasonably well within the grid, but it extends on both east and west side of this grid. And also a very critical thing is that this line had a slightly different angle, and in some places when you're searching for debris and lakes, a slight shift north was very important.
We have a question from Jeff in Arizona. He asks, can XY points from lines and polylines be transferred to the SAS environment, or does it only work with point data? The ability for the SAS Bridge to work with actual geometry will be something that will be in the new version of the SAS Bridge, version 2, that's going to work with ArcGIS 9. At this point, you can store coordinates in a SAS table and actually display them. I'm actually going to show you how to do that here in just a minute.
I'm taking here a question from Jim in San Diego. He's asking, is the SAS table converted to another format when read by ArcMap? No, it is not. The table remains in its original SAS native format, and the SAS Bridge just facilitates transfer between ArcMap and the SAS environment.
And it looks like we have a question from Luke in Memphis. He asks, how does the SAS Bridge differ from ArcGIS Geostatistical Analyst extension? Think of the ArcGIS Geostatistical Analyst extension as having the ability to create statistically valid surfaces. And that's basically what it does. If you want to run other types of statistics, you need to use some sort of statistics package. So the SAS Bridge allows you to run all those advanced sorts of statistics and then link them back to your ArcGIS feature classes.
John from Chicago is asking, linear regression is a very simply programmed in ArcGIS. Why use anything so expensive and complex as SAS? Well, we were in need in a bit more than just linear regression. It was also key for us to document everything we're doing. So the direct output format in HTML in the SAS Enterprise Guide was our first step towards the metadata. But we also were in need getting the residuals out there, because the residuals were used to remove any outliers in our data set. Okay, I think we're out of questions for this topic, and I'll turn it over to Tim Bricker, who's going to talk about using the SAS Bridge for ESRI.
Okay, now that you've seen Herko's case study of what you can do using the SAS Bridge, I want to give you some details on some other uses for it and how you actually would set it up to make a connection to SAS through the SAS Bridge. First of all, what is the SAS Bridge for ESRI? The SAS Bridge for ESRI is a software product that was co-developed by ESRI and SAS. It's built using Arc objects from ESRI and SAS IOM objects from SAS. Both of these are COM-based technologies. With the SAS Bridge, you can view the results of SAS analysis geographically in a map in ArcGIS, perform spatial analysis by joining your spatial datasets to SAS datasets. You can export SAS datasets from ArcGIS, so if you have a feature classes attribute table and you want to do some statistics on that you can only do in SAS, you have this export option with the SAS Bridge, and you can execute SAS stored procedures from the ArcGIS environment. Since we may have some people joining us today that either come from an ESRI background and don't have a deep background in SAS, or vice versa, I thought I'd take just a moment and define some terms. If you're familiar with the database term of a row, in ESRI software this is called a record. In SAS software this is called an observation. The database term of column is referred to as a field in ESRI software or a variable in SAS software. As we go through the rest of the presentation today, you may hear some of these terms used interchangeably depending on whether we're working in the ESRI interface or in SAS software. The SAS Bridge itself works within the ESRI software of ArcCatalog and ArcMap. ArcCatalog is where you manage your data. We'll see ArcCatalog in just a minute. ArcMap is where you can actually display your maps, do analysis, do editing of your data. If you want to run statistics, you can use various interfaces to deal with SAS. The one that we're going to use exclusively is called Enterprise Guide. We use Enterprise Guide because it's very easy to use. It's a GUI-based interface. But you may also use Display Manager, Enterprise Miner, and there's various other interfaces that you can use to interact with SAS software as well. In order to use SAS tables in ArcGIS, you have to have the SAS Bridge installed. Once you have the SAS Bridge installed, you need to define a connection to the machine that has the base SAS software installed. To do that, you go to Database Connections, click Add OLADB Connection. For the SAS Bridge, you'll choose SAS IOM Data Provider 9.0. It will then bring up a dialog that you'll have to enter in the information for the machine that has the SAS software installed. And once you have that information, you can then click on your connection called SAS Bridge here, and you can actually see all of the tables that are available on this installation of SAS. I'll be doing this for you in just a moment in a demo. Once you have that connection defined, you can use your SAS tables to view them in both ArcCatalog and ArcMap. Additionally, in ArcCatalog, you can actually view SAS Metadata. You get an additional tab here called SAS Metadata that allows you to see that data about your SAS tables, such as how many observations there are, how many variables there are, and where on your disk is the SAS table physically located. With a connection through the SAS Bridge, you may also have data in a SAS table that comes in the form of XY values. So you have a field that has X and you have a field that has Y values, coordinates of where something is located. To get these to be displayed on a map, you can use the display XY data function in ArcGIS. So here we're looking at a table available through that SAS connection. We click display XY data. And once we do that, it brings up a dialog that asks us to define which fields hold those X values and which fields hold our Y values. If we then click OK, the software will plot those coordinates on a map. Another way that you may have geographic locations in a table is by address. Of course, addresses themselves are just a big string of information that say where people live or where businesses are located, etc. If you want to get those displayed on a map, you can use a process that's available in ArcGIS software called geocoding. The concept of geocoding is very similar to what you do when you have to visit an address that you don't know where it is. If somebody tells you that you need to visit their business at, say, 380 New York Street, the first thing that you would do is you'd locate New York Street. Once you're on that street, you would then drive along the street until you find approximately the 300 block. and you would know that before you get to the 400 block, you would locate 380. Geocoding is exactly the same thing, it's just the software doing this for you. When the software geocodes, you need some sort of reference data. Typically this is a layer that has streets in it. Those streets have attributes of the name of the street as well as these ranges of addresses for each street segment. So geocoding is the software approximating where an address is based on this reference data. To geocode in ArcGIS, you first set up a geocoding service in ArcCatalog, and then you can use that geocoding service in ArcMap to geocode a table, and that table can come from SAS. So that's what we're looking at in this screenshot here. We've navigated to our SAS Bridge. We're going to tell it we want to get addresses from this Manhattan address SAS table. We'll be doing this in a demo as well in just a moment. There are a couple of types of joins that you may want to do using your spatial data in some sort of ESRI format and your tabular data coming from SAS. The first type of join is called a spatial join. In a spatial join, what things have in common is proximity. When you do a spatial join, you can optionally have an additional field added to the output data set that has the distance of features in another layer that are closest to each feature from the target layer. Another type of join is an attribute join. Attribute joins may be familiar to you if you're familiar with databases or if you come from a SAS background. Attribute joins are joins based on a common key. And if you want to, you can actually join a layer, such as a shapefile's attribute table, to additional attributes that come from a SAS table. We're going to see this later on when Melinda presents her topic. In the demo that I'm going to do in just a moment, we're going to start off with two SAS tables. One of those SAS tables has the coordinates of where fire hydrants are located, X and Y values. The other table that we're going to start off with is a table that contains addresses. But both the address information and the hydrant information comes from an area that had a wildfire burn through in Southern California in fall of 2003. Maybe you want to do some sort of analysis that attempts to answer a question, such as, was the distance of each address from a fire hydrant significant in determining the dollar amount of damage that each address sustained? Another field that we have on our address table is the dollar amount of damage. So to do this, the first thing that you might want to do is get these to be displayed in ArcMap. Since the hydrants table does have those columns X and Y, you can use the add XY function in ArcMap to get those coordinates plotted. For the addresses, since we do have the addresses and maybe we have some underlying reference data, a streets data set, we can perform geocoding. Once we've got them both displayed in ArcMap, if we want to start answering this question, we need to join them together. The hydrants and the addresses have in common proximity. There is no key field that links them together. So this is appropriate for a spatial join. When you do a spatial join, it's going to create a brand new data set that is actually in the form of a shapefile. The shapefile is going to have an additional field on it that contains the distance of each address from a hydrant. So at this point, we have a result, but to see if it's statistically significant, we may want to do some analysis in SAS. In ArcGIS, if you have the SAS Bridge installed, you can export an attribute table to SAS, and you could then do your analysis in SAS. See if there is any correlation between the distance of each address to a hydrant versus the amount of damage that the address sustained. And at this point, I'd like to go ahead and start my demo. I'm going to start off in Enterprise Guide. And in Enterprise Guide, I want to navigate to my SAS user library. In the SAS user library, we can see that table hydrants that I was just talking about. And I just double-clicked on it. It is now opened up. And you can see that there's fields that contain various information about these hydrants. What's really interesting here, though, that we can actually use for a map is the X and Y coordinates. So we can use these to plot in a map in just a moment. The other table I want to show you is this address table. The address table contains these addresses of all those addresses that were within the perimeter of this wildfire that burned through Southern California, and we have a field called damage that records the dollar amount of damage that each of these addresses sustained. Notice that some of the values here are 0, meaning that not all houses were damaged. If I scroll down, we can see that there are some significant dollar amount of damage. In fact, some houses were destroyed completely. The first step in trying to answer this question is to work with the data in ArcGIS. So I'm going to open up ArcCatalog. And there already is a connection through the SAS Bridge defined. Just so you can see how this is done, I'm going to remove it and create a new one. Again, the type of connection through the SAS Bridge is an OLADB connection. And I'm just waiting for it to open. Once it opens up, it brings up a dialog that asks me what sort of data provider I want to define. Again, for the SAS Bridge, it's a SAS IOM data provider. If I then go to the Connection tab, for data source, you type in the name of the machine that actually has the base SAS software installed. The name of the machine here is Encoder 2. If I click OK, it defines that connection, and notice how it brings up a box that allows me to change the name of it. The default name is OLADB connection. You may have other types of OLADB connections, so you might get confused if you don't rename it. I'm going to name this SAS Bridge, since this is my SAS Bridge connection. If I now double-click on the SAS Bridge connection, I can see all of those tables that are stored as SAS tables. And if I scroll down, we can see the hydrants table that we were just looking at in Enterprise Guide, and the address table that we were just looking at in Enterprise Guide. At this point, I'm going to go into ArcMap, and we'll see if we can get the addresses and hydrants plotted in ArcMap. I'm just going to open up a brand new MXD document that contains some background information. Once it comes up, you'll see that there's a background streets layer and a background raster. These are just so we can kind of orient ourselves. The streets layer here is actually the layer that's going to be used for geocoding when we do the addresses as well. So the first thing I want to do is I'm going to go to Tools, Add XY Data. And I'm going to click the Browse button, and this allows me to browse to some data that has X and Y values that I want to plot. The data that I want to get, I'm going to get through my SAS Bridge connection. So again, here's our hydrants table. I'm going to click Add. It's automatically detected which fields hold those X and Y values. If you're doing this, you may want to confirm that it has chosen correctly. So we know where to get the coordinates from. What the software doesn't know is what the units of those coordinates are. So I'm going to tell it that by clicking the Edit button here, clicking Select, and I happen to know that the projection of those coordinates are in a UTM projection series, and it's actually UTM zone 11, which is the UTM zone that covers Southern California where this wildfire was. Now that I've told it UTM zone 11, it knows that the units are meters. Meters are typically the units for UTM projection series. When I click OK, it's going to bring me back here, and when I click OK again, it's going to go ahead and go through that table and plot using those coordinates. And notice it's added these points to the map. They look like little brown dots. If I want to, I can actually make a permanent data set from those points. Right now, they're just stored as a layer in this ArcMap document. So I'm going to export data, and it's asking me where I want to store this new data set. I'm going to store it in my temp directory. I'm going to call it hydrant.shp. So I'm going to make a new shapefile. And I am going to add that new shapefile to the map. So I'm going to get rid of this layer, and now we just have the hydrant shapefile displayed in this map. The second thing I want to do here is go and get those addresses. So I'm going to go to Tools, Geocoding, Geocode Addresses. Again, in order to geocode in ArcGIS, you need a geocoding service. I predefined that in ArcCatalog. Basically, the geocoding service points to that reference data, the streets layer. Now it's asking me which table contains addresses that it wants, that I would like it to plot for the map on, for me on the map. I'm going to find that address table, and just like with the X and Y's, it's automatically detected the field that holds those address values. I'm going to tell it that I want to create another new data set. I'm going to store it in my temp directory. I'm going to call it address, address.shape. So it's going to make a shapefile of these addresses. When I click OK, it's going to do a little bit of thinking, compare each of those addresses to the underlying reference data, and attempt to locate each of those addresses. Once it finishes up, we get a summary of how well it did. And actually it did pretty good. It wasn't able to match about 3% of the addresses, and this could be because of things like misspellings in the SAS table versus the reference data, etc. If I wanted to, I could actually geocode again and make it less picky, but I'm fairly satisfied with these results, so I'm just going to use what it's given me. I'm going to click Done, and you can see that it's added that new shapefile to our map as well. Let me just make the addresses kind of a different color here so we can see the difference. I'm going to make my addresses kind of yellow. And I'm going to make my hydrants brown. Okay, so now we have the data displayed in the map, and we may want to start trying to answer this question of, is it significant how far each address was from a hydrant versus how much damage each address sustained? So to do that, we need to join them together. To do a join, you can right-click on a layer. I'm right-clicking on the addresses here. Go into Joins and Relates, Join, and I'm going to choose Join data from another layer based on a spatial location. So this is going to be a spatial join. It automatically fills in here that I'm going to join to hydrant, but you could choose another layer if you wanted to. I'm going to click this radio button here that's going to say add a new field to the resulting output data set that contains this distance of each address to its closest hydrant. And since it is making a new data set, I'm going to tell it where to put it. Again, I'm going to put it in my temp directory, and I'm going to call it join output. And it's going to be a new shapefile. So I'm going to click OK here. It's going to do a little bit of processing to figure out which hydrants are closest to each of those addresses. And once it's done, it gives me this new layer automatically added to the map. Let me turn off the other point layers here. And if I go to the attribute table for this output data set, we can see that all that information, such as the addresses, are in this table. And if I scroll all the way to the end, I've gotten a new field called distance. So the distance field contains the distance of each of these addresses to the hydrants. We can kind of visually see the results at this point, but what if we want to run some analysis to see if there really is a significant correlation between distance and damage? Well, at this point, we may want to do some processing in SAS. So what I'm going to do here is right-click. Since I do have the SAS Bridge installed, when I go to Data, I get the option Export Attributes to a SAS data set. And it's asking me where I want to store this and what the name of that output SAS table should be. So it's going to be called export_output. When I click OK, it does some processing to export that to SAS, and it gives me a little summary. It exported about 7,100 features to a SAS table. So let's go back into SAS, actually into Enterprise Guide, and work with SAS. If I refresh this library here, I can see that I've gotten this new table called export_output. Let me just double click on that, open it up, and it should look the same as what we just saw in ArcGIS. It's just now a SAS table. So since we are here in Enterprise Guide, we might want to run some sort of correlation. and figure out if there is any significance to this relationship between distance and damage. So I'm going to click on the correlations task, and it's basically asking me what I want to compare. So I want to compare distance and see if that correlates with damage. If I go to the correlations tab, it's already going to run a Pearson correlation. I'm going to have it run a Spearman for me as well. And if I go to the results tab, I'm going to tell it that I want to actually plot the relationship for each of these rows. And you could change the titles as well. I'm going to go ahead and have it run. Once it runs, the output is actually in HTML format. So it's giving me the results here. And I'm going to take a look at this number right here. This number here represents the correlation coefficient. If this number was close to 0.99, it would mean there's a strong positive correlation between distance and damage. Well, 0.15 is not near 0.99, so you can tell that really there's no correlation. And if we want to visually see the result, we can scroll down and it's plotted those. And clearly there's really not much of a correlation here between distance and damage. So if we were a insurance company wanting to raise rates for houses that were farther away from hydrants, we probably wouldn't be justified in doing that, at least based on this data set. What if we do want to make some sort of product that's suitable for printing that we want to give to our boss, though? We may want to do that by including this graph in a map. So I'm going to just copy this here. Since the result is HTML, this graph itself is just an image in an HTML document. And I'm going to go back to ArcMap. If I click this piece of paper here, it's going to go to Layout View. And I can actually include that graph by just pasting it in. So maybe I want to print this out and give this to my boss or whatever. Okay, at this point, I want to just do a quick review. We talked about the SAS Bridge for ESRI, what it is, some of the capabilities of the SAS Bridge. We went over how you create that connection to SAS through the SAS Bridge once you have the SAS Bridge installed. It's an OLADB connection. And we went over some of the capabilities. Displaying SAS data in a map, if it comes in the form of X and Y, or if it's in the form of an address. And we did a spatial join, and then we went back to SAS, and we figured out the answer to that question. At this point, we'd like to take a few more questions.
I'll take a question from Karen from Toronto. She has a question regarding what criteria we use to eliminate outliers during the shuttle recovery debris effort. Remembered we computed the residuals and we made a judgment call on site to remove all residuals that were 2 times the standard deviation away from the main line, essentially removing 5% of our observation population.
Looks like we have a question. After defining XY in ArcGIS for a SAS dataset, what happens if the underlying dataset is refreshed or replaced by another dataset with the same structure? Once you have exported to SAS, the SAS table doesn't have any connection with the spatial data, so you'd have to export again to get that updated.
We've got a question about SAS for the PC versus SAS for UNIX. The question is, could we use basically SAS for UNIX to connect to ArcGIS? You can in version 2 of the bridge, which is coming out in June. So right now it's only for the PC, but coming in June you're going to be able to use UNIX or the mainframe if you need to.
And a question from Laura. Before this presentation I had never heard of SAS. Is SAS an extension of ArcGIS? No, SAS is not an extension to ArcGIS. SAS is a company that's actually located in Cary, North Carolina. SAS has a history of being very robust in statistics, but at this point you can do lots and lots of stuff with SAS software. In a moment you're actually going to hear from Melinda, who's from SAS. So Herco and I work for ESRI, and Melinda works for SAS, and she may want to explain a little bit more about SAS.
Okay, and I've got one more question. I think we have time for one more. The question is, can raster cell values be exported to SAS? Again, in the version that's coming up in June, yes, you can move raster data into SAS. Right now we're sticking with point and attribute data.
Okay, at this point, I'm going to hand it over to Melinda, and she's going to talk about the last topic for the day.
Okay, well, Tim and Herco have kind of talked about the nuts and bolts of moving the data back and forth. Now I'm going to start building a model using ArcGIS and SAS. So what you see on the right hand of your screen, someone asked in the queue, is it possible to display county level data using ArcGIS and SAS? Yes, it is, and actually what I've done is displayed census block level data. So I've got a layer in the map that shows me where the census blocks are, and I joined the SAS data to that census block using a unique key. I'm going to show you that technique in a few minutes. This is a violent crime map. So what I've done is color the census block by the number of violent crimes that occurred in that area. I had to do some summaries in SAS, and then I joined that SAS data with the census block layer. One of the issues here, people will often try to use a map like this to make decisions, like where should we put our police force? But the problem with reporting is that reporting really looks backward. So maybe that's 2003 data. I'm sitting here in 2004 trying to make decisions. Well, neighborhoods change, places change, and so what we really want to know in 2004 is where are the violent crimes going to occur in the future. So what I'm going to do is build a predictive model in SAS using my 2003 violent crime data. So here we are, we've got this variable called vCrime. vCrime has a 1 if at least one violent crime occurred in that location and a 0 otherwise, and I have a row for each location. This particular outcome has a limited number of possible values, so what you saw with Herco with linear regression, that's not really appropriate. We're going to use logistic regression, which is what is useful for this kind of data. Okay. So I'm going to do this logistic regression on my existing data, on my last year's data, and then I'm going to do predictions for next year's data. After that, I'm going to summarize the resulting predictions so that I can actually join that with my layers in my map project. So now what we're going to do is go ahead and start Enterprise Guide. I'm going to pick a project. A project is basically a way to organize your data files and your results. Herco and Tim have already shown you how to add data to the project, so my data is already there. I've also already created a logistic regression task. If I double-click that in my project, it's going to show you all of the clicks that I performed earlier. So I have this Columns tab, and what I've done is I've said, okay, vCrime is my outcome. So vCrime is going to be what I want SAS to model, but I have all of these possible predictors. This is a great big data set. Now I know these aren't all important. So what I'm going to do is go to my Model Builder tab. There are two different things I can do here. First of all, I can specify interactions. So I've got an interaction between X and Y. I can also specify nonlinear effects. So if you think you've got a parabola as your underlying function, you could actually specify a squared term or even a cubed term like I've done here. Also, I want SAS to help me find the important variables, so I'm going to do something called a forward selection. The way I've set it up here, this says, okay, in order to enter the model, you need a 0.01 significance level. I've set that significance level rather low because I'm concerned about overfitting. I'm worried that my p-values are going to be artificially small, and I'm going to get a lot of terms that look important but actually aren't. So I'm going to click OK here. And that's really all we're going to do. Now there are lots and lots of ways to look at this model and analyze it and make sure it's giving you the best predictions possible. You could spend some time here doing that, but for this demo, I'm just going to go ahead and click Finish. And now what it's going to do is run the model, and it's going to show me at the bottom of my output which variables it included. Okay, so these are all the variables that SAS found significant. Now what I'm going to do, so this is my training data set. This is the data set from earlier that I used to build the model. Now I'm going to go to the data set I want to predict for. Again, I'm building a logistic regression task, And now what I'm going to do is use the model that my earlier data set gave me. I'm going to use those significant predictors in those terms, but now I'm going to ask for predictions. So I'm going to tell SAS, I want you to predict which of these are going to be violent crime locations in the future. So I'm asking for predictions, I've given it a name, and then I'm going to click Finish. Would I like to replace the results? Yes, that just says I've done this before and I have some results already created. And now I have the SAS data set that contains predicted values. Now it's going to have all of the information from before, plus it's going to have an extra variable called underscore into underscore. That's my predicted 0, 1. 0 again means I don't predict a violent crime in this area. 1 means there is a violent crime in this area, or that we predict there will be at least 1 in this area. And that little red triangle means that that's a character value. So it's not actually stored as a number, it's stored as the character 0 or the character 1. Now let's talk about taking these results and displaying them in ArcMap. So what I'm going to do is build a query in Enterprise Guide to change my data and basically get that data ready to import. Your data is hardly ever exactly the way you need it when you have it. One of the things SAS can do is change your data and make your data into the form you need it to be. Once I do that, I'm going to join that resulting attribute table to a layer in ArcMap. I actually have attribute data. So this is I've got a row for every census block, and I want to join my census block data to the existing layer in ArcMap. What this is going to let me do then is create a map from the results of a predictive model. So I've taken these really complicated numbers, I've got this underscore into underscore. What does that mean? Well, they don't have to know. I can just show them this map, and they can get a good picture. And they don't have to sit there and pore through all the numbers. So let's go back to Enterprise Guide. So here I am, I've got a row for every location. I could, if I wanted to, just map that location directly. I get a set of points, but the points don't make a very pretty map. So I'm going to go up to Data, Filter, which opens my query builder, and I'm actually going to, first of all, change that underscore into underscore variable so it's a number. I'm doing that because I want to count the number of violent crime locations in my map. Okay, so I'm going to go to Properties. I'm going to call this num into, just so that I know that it's something I created and not something SAS created. I'm going to go to Replace. I'm going to replace the character 0 with a numeric 0. And I'm going to replace the character 1 with a numeric 1. Then I'm going to click OK. The other thing I'm going to do is go to my filter. Now I'm still going to get a row for every location, but some of those rows are dirty data. They don't have the correct block group, or they don't have a block group at all. I want to filter those out, so I'm going to go up to Block Groups ID, drag it onto my Filter tab, and select all the block groups where block group is not null. So I say is null, and then apply not. Click OK, run the query, and now I have only non-missing block groups plus my variable num into. Now I want to collapse these rows by block group, so I've only got one row for each census block. So I'm going to go back to Data Filter. I'm going to go back to my Select and Sort tab. I'm going to set block group as a group variable that says I only want one row in the resulting table for each value. And then I'm going to sum num into, so I want a total. Don't really like that name, sum of num into, so I'm going to call it total crime. That's my query. I'm going to click Run. Okay. Creates this table, and if I right-click on the table and go to Properties, I can see that SAS called it sasuser.query8852. Now that's a default name. I could have changed that in my query builder if I'd wanted to. I'm just going to leave it the way it is for now, though. So now my data is ready to go. My data is set up. I'm ready to join it in with my ArcMap layer. So I'm going to open up my database and give it a second to open. And this is my original crime map. It's actually coded red instead of the blue and green that you saw earlier, but it's the same numbers. Now what I've done then is I've joined by block group the original data, the data that I built my model from. Now I want to go in and change it. So I want to get rid of, and that wasn't what I wanted to do. I want to go in and change it. So I want to get rid of the original join. And I'm going to go in and I'm going to join my new table. So I'm going to say joins and relates. I want to join. I don't want to join based on space now. I want to join based on a common key. So it wants to know, well, what is your common key variable in your layer? Well, it's block group's ID. What table do I want to join to? Well, I want to join to a SAS table. So I'm going to go find that SAS table that I created earlier. And then it says, well, what field in the SAS table is your common key? Block group's ID. I click OK here. And it's always a good idea to open that attribute table once you've done that and make sure you've got the right data. So I can scroll over to the side. I can see my total crimes. Those null values are basically block groups, or they're census blocks where no crimes occurred or I didn't have data for them. Now, I've got that information in the map layer. I can go to properties for that block groups layer, go to quantities, and I can say, okay, I want you to color those block groups based on the value of total crime. This is a color ramp, and so what it's going to do is for low values of total crime, it's going to display this kind of pinkish color, and for high values, it's going to display a red. Click OK. Now I've got this nice colored map. I can hand this to my decision makers and say, all right, based on what you see here, you can decide where to employ your police force, where to put them. That ends the demonstration. So what did we talk about? Well, we talked about how to take basically a layer in ArcMap and then join some SAS data with it. We also talked about joint reporting versus modeling, and we talked a little bit about how to develop a predictive model. Now we're going to take some questions.
Looks like we have a question from Nancy. She asks, can the SAS Bridge be used with SAS for Windows? Actually, that's what we're doing here. We're working on a Windows platform, but the SAS Bridge can be used with SAS installed on any of the platforms supported by SAS.
Okay, we have a question from Lauren in North Carolina. She's asking, what are the assumptions of logistic regression? The assumption for logistic regression is basically what I'm doing in the background is called a logit transformation. What I'm assuming for the most part is that everything is a straight line in terms of that logit. I'm modeling a probability. Probabilities don't have to be normally distributed. I'm not required to make that assumption, but there are certain assumptions about the error terms in the background. I'm doing a predictive model. If it's a predictive model, those assumptions are not quite as critical. There are ways to check those assumptions in SAS.
Looks like we have a question from Amit. He's asking, is Enterprise Guide different than base SAS? And does the SAS Bridge work with base SAS? Think of Enterprise Guide as a client to base SAS. So Enterprise Guide is a client. It is different than base SAS. If you are familiar with other interfaces to get things done in SAS, those work as well. Basically, the SAS Bridge gives you access to those SAS tables once you have done your analysis. There's a few comments that Fiona from SAS may want us to make, and this may answer a few other questions as well. First note is that the SAS Bridge is available from both ESRI and SAS. And Fiona wants us to mention that points that I was showing you, X and Y, is something that you can do with this version of the bridge, but in the next version of the bridge, we'll actually be able to handle spatial geometry using the combination of SAS, the SAS Bridge, and ArcGIS.
Okay, I have a question about, can Enterprise Guide do kriging and co-kriging? You can do those procedures. There is some kriging available in SAS, but not through the point-and-click interface in Enterprise Guide. So if you wanted to do some kriging using SAS, you would need to write some code.
And it looks like we have a question from Mary Beth. She asks, have you created a library of scripts for bringing data from SAS into ArcGIS? And if so, is it available? Actually, there is no library of things that bring data from SAS into ArcGIS. That is the function of the SAS Bridge itself. Again, When you set up that connection through the SAS Bridge, you can just get to all those SAS tables, so you wouldn't need another library of scripts. That's the job of the SAS Bridge.
We have a question from Rob and Madison. What is the difference between linear and logistic regression? Basically, linear regression assumes that you have what's called a continuous variable. It also makes some assumptions about the shape of your error terms, etc. Something that Herco was working with, where he had a continuous set of y values that could take on any number of values on that range, that was really good for linear regression. If you're talking about logistic regression, you're saying that your outcome variable is basically a variable that only has a few possible unique values.
Okay, it looks like we're about out of time. If you would like some more information about ESRI software, the SAS Bridge, and SAS software, we have a few resources listed here. If you want to get information specifically on the SAS Bridge, we actually have a pre-ESRI user conference one-day workshop that you might want to attend. We have the URL for that listed here. For SAS software, specifically SAS and the Bridge, we have a resource listed. For ArcGIS software in general, you can go to www.esri.com/software/ArcGIS. And for SAS software in general, you can visit www.sas.com. These resources will be available on this archived presentation, which is going to be available on the ESRI Virtual Campus in a few days. On behalf of ESRI and SAS, I'd like to thank you all for attending.